Hello and welcome back. Sorry for that disruption. I'm sure if any of you have dogs, you'll know that they can be easily distracted by a leaf in the front yard. So anyway, let's go over this here. Okay, so I have when finding the probability, you always want to round to 4 decimal places. The reason we want to round to 4 decimal places is because when we write our answer, because we're looking for a percent, so the probabilities are expressed as percent, is because we want to express our probability as 2 decimals for the percent. So in order to do that, we have to have our answer as 4 decimals. Okay, so let's look at this first one. I want to round 0.783468 to 4 decimal places. So when you're rounding to 4 decimal places, you're going to look at the 5th one. So my 5th decimal place is 6. Well, the rule when rounding is if it's 5 or above, you want to round up. So you change the number 1 up. If it's below 5, then you round down, which means it stays the same. So if I'm looking at this one, so 6 is greater than 5, so I'm going to round up. So this becomes 0.7835. Okay, let's look at the next one. So again, I'm going to round to 4 decimal places. So I want to look at the 5th one. Well, in this case, it's 4. So 4 is less than 5. That means I want to round down. So that means I keep it the same. So 0.832. And that's all there is to that. So like I said, the reason we want to go 4 decimal places is because when we write our answer as a percent, it is with 2 decimals. So let's practice. I want to convert 0.9345 to a percent. So what you do is you just move it 2 to the right. So that gives me 93.45%. If you don't want to move it 2 to the right, you can also just times your answer by 100, or in Excel, you can actually express your answer as a percent and it will do it for you. So there's 3 options on how to get it from decimal to percent. Okay, so let's look at the next one. I want to convert 0.0021 to a percent. Okay, so this one, it's going to be 0.21%. Since it's less than 1, I'm going to include the 0 in front of it. Okay, just as that placeholder. And that's my answer. Okay, so let's actually go ahead then and do some practice. Okay, so I want to find the normal distribution. Okay, so I'm given normal distribution. I want to find the probability that x is less than or equal to 69. So my mean is 67. My standard deviation is 3.7. Again, to do this, if you go back, I'm just going to be using this equation right here in Excel. Okay. So I'm just going to bring up a blank Excel. So let's plug it in. So equals, so the norm distribution, okay? So my x in this case, that was 67. So I'm going to go ahead. So again, I'm looking at this one here. Hold on 1 second while this comes back up. Okay, there we go. So let's go ahead and go back to answering this. Okay. So I want to do, the mean is 67, standard deviation is 3.7, and then ours. So this is 69, so I'm going to put in 69. My mean was 67, the standard deviation was 3.7, and again, this here is always true. Okay, and then I hit enter, and I get 0.70559. And that is my answer. And if you do want, here, let's go ahead. I'm going to write this down here. So this is equal to 0.70559. Okay, well, if I rounded 0.7056, So this is equal to 70.56%. Okay. And if you want to just do that as a percent, what you can do is you can hit equals, and I'm going to click this one here. And then on my, let's see here, it's a little bit different on my iPad to write it as a percent. Well, I'm just going to, in this case, times 100 and hit enter. So there you go, 70.56%. Okay. Okay, so let's do this next one here. So I want to find the probability that it is greater than 51. So the first thing I need to do with this, remember, if I'm finding the probability that it's x is greater than 51, it's 1 minus the probability that x is less than or equal to 51. Okay, so let's go ahead and find that. Okay, so again, I'm just going to use one here. So equals my norm distribution. Okay, so again, with this one here, I'm using 51. So I'm going to type in 51. And everything else stays the same. My mean is still 67. The standard deviation is 3.7. And again, this is true. Okay, so hit enter. So I get that answer there. Now that one looks weird. 7.7 e to the negative 0.6 means that the number is really, really small. So I actually would have to move the decimal 6 places to the left to even see it. So that means that number is 0.000077. Okay, so pretty small. Now, what I want to do to find my answer is I still have to subtract 1 from that. Make sure we want to cell reference our answer, so I'm going to hit equals 1 minus, and then it's this one right here. So I click that to give me that value, and then I hit enter. So then I get 0.99999. So 0.9999, which is 99.99%. And that's my answer. Okay. So let's go ahead and do the next one. So I want to find the probability that x is between 53 and 65. So what is the percent? So remember, when it's an in-between one, you want to find each of them. So the probability that it is less than 65, and I want to find the probability that it's less than 53. Okay, so again, let's go ahead and go over here. Okay, so I'm going to go ahead and plug that in. So I have my norm distribution. Okay, so this one here is, so let's just start with the smaller one. So I have 53. Again, 67, the standard deviation is 3.7, and it's true. And then I hit enter. Okay, so I have that answer here. So now we're going to go ahead and do it again. This time, there we go. So this time we want 65, so I'm going to go ahead and type 65. Go ahead and type everything in. Okay. Hit enter. Okay, and now remember what we're going to do is we're going to take the bigger one minus the smaller one to get our answer. So again, you want to, don't do this by hand, you just want to do everything in Excel. So I'm going to hit equals, and then it's this one because that's the bigger one minus the smaller one, and then I hit enter, and I end up getting 0.2943. Okay. So this is equal to 0.2943, and then as a percent, that would be 29.43%. So again, don't do any of this by hand, do everything in your Excel. It makes it a lot easier too. Okay, let's do another one. So assume that pizza delivery times are normally distributed with an average of 30 minutes for delivery and a standard deviation of 5 minutes. So average, okay, just remember average is your mean, so we know it's 30 minutes, and our standard deviation is 5. Find the following probabilities. So what is the probability that a pizza is delivered less than 22? So I'm finding the probability that it's less than 22 minutes. Okay, so if I'm looking there, it's probably not a great chance. Okay, just looking at where 22 falls on my bell curve, but let's see what that percent is. Okay, so let's go ahead and go into Excel. Just gonna pick a new one here. So again, equals my norm distribution. So we wanted it less than 22, so 22. The mean was 30. Standard deviation is 5. And again, this is always true. Okay, so I get 0.0548. Which gives me 5.48%. Okay. So let's go to the B. What is the probability that a pizza is delivered between 26 and 36 minutes? So how I would write that. So it's between 26 and 36. Now remember with this one, I have to find the probabilities of both 36 and 26. And then I need to subtract them. So let's go over here. Okay, so let's do those. So again, my normal distribution. I'm just going to start with the lower bound. So I have 26. Again, 35. True. And I'm going to hit enter. Okay, so I have that number. Now I'm going to go ahead and do that with 36. So equals my norm distribution. So I have 36. Again, my mean is 30. Standard deviation is 5. And this is true. Hit enter. Okay, so now I have both probabilities individually. And then to figure out what the percent or probability that it lies between there is I subtract the bigger from the smaller. So equals, well, this is the bigger number, minus the smaller, hit enter, and I get 0.67307, so that would round to 0.6731. Which then is 67.31%. So let's look at this last one now. What is the probability that it takes more than 42 minutes to be delivered? Just looking here, so 42 is probably here, so it's probably not that much, okay? So I can be safe to assure that I should be getting my pizza in less than that. Let's see how that does. So more than 42. Again, if it's greater than, that means we do 1 minus the probability that it is less than that. Okay, so let's go ahead to our Excel. Okay, so again, normal distribution, 42, 35, true. Okay, hit enter. Okay. So again, remember, that's saying that's to the left. So that would be less than 42 minutes. So if I'm interpreting that, that means that this pizza company, 99% of the time, I'm going to get my pizza less than 42 minutes. But we're saying, what do we want if it's more than 42? So then I'm going to go equals, 1 minus, again, make sure you cell reference and hit enter. So 0.0082. And again, that as a percent would be 0.82%. So it's a less than 1% chance that it would take more than 42 minutes to get your pizza. Okay, so this next example here, okay, I actually would like you guys to do on your own. So what I mean by that is you're going to go ahead and pause the video and then come back and check your answers with me. So good luck on it. Welcome back. Okay, let's check our answers. So let's see what we have. So we have a mean of 70 and a standard deviation of 2. So the first one is saying, what percent of adult males are shorter than 65? Okay, so how I would write that, x is less than 65. Okay, so let's go ahead and go over here. So equals, again, that norm distribution. Okay, so I want it less than 65, so 65. My mean is 70. The standard deviation is 2. And again, this is true. I'm going to hit enter. So I get 0.00621. So that would be 0.0062. And as a percent, that would be not even 1%. So it'd be 0.62%. So it'd be very rare that someone would be less than 65. Okay, so let's go to the next one. Approximately what percent of adult males are taller than 73? So are taller than 73. So remember, if it's greater than, we have to do 1 minus the probability that it's less than 73. So let's just go ahead and plug that in. So here I have 73. And again, everything else stays the same. Oops, that's from the last problem. Okay, so I get 0.93319. That rounds to 0.9332. But remember, it is, whoops, I got ahead of myself there. So that read it to the left, but I want it taller than, so I have to do 1 minus, so equals 1 minus, and again, cell reference it, so hit enter. So I get 0.06681, so that'd be 0.0668. Okay, and then that would be 6.68%. Okay, hopefully you're doing well. So let's look at the last one. What is the percent that it is in between 72 and 73? So again, if I was writing that, that's going to look like this. Okay, so again, I have to find the probability of each, and then I subtract. Okay, so we're going to start here. So we can just pick the first one. So 72, 70. My standard deviation is 2 and true. Okay, so hit enter. So I get 0.84134. Well, so that's 72. Now remember, we actually found for 73, that would be this one right here. Okay, so if it's 73, so now we can just subtract the bigger from the smaller. So this is equal to 73 minus the probability that is less than 72. Ooh, I have no idea what happened there. There we go. We're just going to start this 100% over because I have no idea what it's doing. So equals this minus this. Oh, I see what I'm doing. I don't know what is doing this. Okay, so equals this minus this. So in this case, what we're going to do, since it's being weird, let's just go, and everything got erased. So sometimes this is always fun. Okay, there we go. So the probability, so here is 73, here is 72. So again, see if it equals this minus this. That has never happened to me. So equals, I'm just going to retype it in here. 72, 70, standard deviation is 2, true, enter. Weirdest thing. Never seen that before. So, and I guess this is good to show. So if for some reason it's acting up your Excel and it is being weird, just go in and retype it over again, because sometimes there's just weird glitches. Okay, so I get 0.09185. That rounds to 0.0919. Which is 9.19%. Okay, so that would be, there we go. So hopefully you did well on that. Okay, let's look at this one here. So annual salaries for a large company are approximately normally distributed with a mean of 50,000 and a standard deviation of 20,000. What percent of company workers make under 40,000? Okay, so I want to know what is the percent that they make less than 40,000. Okay, so let's go ahead and go into Excel. Just gonna clear that. So equals the norm distribution. So here I have 40,000. My mean is 50,000. And my standard deviation is 20. And then the cumulative, again, that is true. And hit enter. I get 0.30854, which is 0.3085. Which is 30.85%. So almost 31% of the company is making less than $40,000. Okay, let's go to the next one. What percent of company workers make at least 90,000? So at least means that that's going to be greater. Okay, so greater than means it's 1 minus the probability that it's less than 90. Okay, so equals norm. Okay, so here we have 90. Again, the mean is 50. Standard deviation is 20. And true. Enter. Okay, so 0.97725. Again, remember that means that less than the company makes 90,000. We want more, so we got to subtract 1 from it. 1 minus that. And I get 0.02275, which will round to 0.0228. Which is 2.28. So only 2.28% of that company makes $90,000 or more. Okay, so let's do this last one. So what percent of the company workers make between 35 and 55,000? So again, how I would write that, so it's between 35,000 and 55,000. And remember, you have to find the probability of both, and then we subtract. Okay, so let's go ahead and go here. So I have equals my norm distribution. Okay, so the first one here, let's just do 35. You guys will be experts at this by the time we're done. Okay, so that is less than 35,000. Now let's go ahead and do less than 55,000. Okay, and then again, remember to get the probability, now we want to subtract. Okay, so make sure you cell reference. Oops, there we go. And I get 0.37208, which is 0.3721. Which is 37.21%. Okay, so we got a lot of good practice in today. So just to review, there are two types of quantitative variables, discrete and continuous. Probability is the quantification of uncertainty. A probability distribution is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. And we only looked at the probability distribution of a continuous variable, which looks like a curve. So again, that means we're finding that area under the curve. One type of continuous variable distribution is the normal distribution. So your variable here is x. The mean, median, mode are all the same, so that's why it's symmetrical. And to find the probability, use equals your norm.dis. And again, you put in your x variable, the mean, the standard deviation, and always true. The area under the curve, which is also the probability of a normal variable, can be calculated using the norm.dist function in Excel. The probability given represents the probability of the value being less than the number. If we have to find a value greater than, that's when you find the probability that it's less than, and then do 1 minus that. And then to find a value between two numbers, you find the probability of each and subtract the values. Okay. If you have any questions, let me